So, good evening friends. Welcome back to ACE Academy YouTube channel. So, yesterday we discussed about the preparation strategy for geomatics engineering, that is for surveying in civil engineering. Okay. So, we saw what is the weightage analysis. Okay. I told you which are the topics which carries the highest weightage. Okay. How to prepare from them. A small guideline also we discussed. So, today we are back with a small discussion on some important concept in a surveying. Okay. As I told you yesterday, the most highest weightage is coming from one chapter that is known as leveling. Okay. So, we will start we'll discuss about one particular topic in leveling. Okay now, right. So, before we start, I will just like to talk about what is meant by leveling. Okay. So, leveling is defined something like this. Okay. What do you mean by leveling? Okay. Leveling is the branch of surveying that deals with measurements in the vertical plane. So, what is leveling? I will write like this, right. It deals with measurements in vertical plane. Deals with measurements in vertical plane. Measurements in which plane? In our vertical plane. Okay. So, this is what we call our leveling as. Okay. In vertical plane. Now, please understand when I am saying measurements, okay, it is plural. Matlab, there is more than one measurement involved. Both my vertical distance and my vertical angles are involved in our leveling. Okay. But today we will talk about one small concept regarding spirit leveling only. That means regarding vertical distance only. Vertical angle discussion we will not have today. Okay now, right. So, this is what we will define our leveling as. Now, what are the objectives of leveling? Why do we have to do leveling? There are two main important objectives of leveling, starting with first one. Right. Number one, to find the elevation of a given point. I give you a point in the field, I ask you what is the elevation of that point, you have to do leveling and find the elevation of that point. That is the first objective, to find the elevation of a given point. Number two, just the opposite of this, fix a point at a given elevation. Okay, now I give you the elevation, you fix it in the field. For example, I will say that the sill level of my dam, that the top level of my dam should be at a 250 meter height from the ground. You have to do leveling and establish that particular height. Understand? So, these are two objectives, just let me roughly write it down. To find elevation of given point, to find elevation of given point, okay na? And number two, just the opposite of this, that is to fix a point at a given elevation, that's it. Okay, these are the two objectives of our leveling. Now, there are different types of leveling, right, like for example, fly leveling is there, differential leveling is there, simple leveling is there, followed by check leveling is there, profile leveling is there, cross sectioning is there, followed by reciprocal leveling is there, right. So many different types of levelings are there. Now, for our exam point of view, one important type of leveling is what we call it as differential leveling. Okay. So, what do you mean by differential leveling? Rather, when will I go for differential leveling? See, I will go for differential leveling, right, when the distances between the points, right, under consideration is very, very large, the difference in elevations between the points are very, very large, or when there is an obstacle present in between the 2 points. Okay, now, I have point A and point B, if they are very far apart, the difference in elevations are large, or when there is an obstacle present in between A and B, I will go for differential leveling. Okay, now, right. Now, one way of defining differential leveling is something like this. I told you the field condition. One way of defining differential leveling is that, see, it is the, or I can say like this, right. Here, I will find out differences in elevation irrespective of the horizontal position, right. Differences in elevations are calculated irrespective of the horizontal position, which means I do not care where my points lie in the horizontal plane, okay. I still, right, can find the difference in elevation. The points may be 10 meters apart or 100 meters apart or even 1 kilometer apart, I do not simply care. I still find out what the difference in elevation is. No horizontal distances are measured, only vertical distances are measured. That is the understanding. So, I can conclude like this, differences in elevations are calculated irrespective of their horizontal position. That is it. That is what we call it as differential leveling. Right. What I want to discuss here is, what are the different terminologies that are involved in my differential leveling work? What are the different terminology that are involved in our differential leveling work? Okay. Starting with the first and foremost terminology, what is meant by backside, right? What is meant by backside? Okay now. So, this is one very important definition that we should know. What is meant by backside? Okay now. Now, can you please answer me? Can you please tell me what is a backside is? Anybody? What is meant by a backside? See, let me guess. Your answer is the first staff reading taken as a backside. Is it true? Yes or no? The first reading that you take in a leveling work is a backside. Is that true? Yes or no? It is only 50% true. That is only half true. Why? Because if you say that the first reading taken is a backside, you are indirectly also saying that all throughout the leveling there is only going to be one backside. Correct na? You are indirectly also saying that all throughout the leveling work you are going to only have one backside. Now we both know that that is not really true. We can have multiple backside na? Yes. So the entire definition of backside is not only the first staff reading taken. Okay, there is something more to it. Let us try and understand. Okay. So what I'll do is I'll just give you one small field condition here. So you imagine that we are having a ground that looks like this. Okay. You imagine that we are having a ground that looks like this. What I need to do is I need to find out the differences in elevations between, let us say, a point here A and a point here say B. So this is what happens even in your college also. Teacher will say take A and B, right? Find the difference in elevations between A and B. This is our ground. Okay. Right. Now remember, all leveling work will always start from a benchmark only. Right. All leveling work will definitely start from a benchmark only. Right. So what is meant by a benchmark? Benchmark is nothing but a point of known elevation. Right. Benchmark is nothing but a point of known elevation. The teacher will say take that particular point A as a benchmark of 100 meter elevation. Right. That's it. Immediately what you do? Right. Once you got this particular information, immediately what you do? What you do is you bring in your leveling staff. Okay. You bring in your leveling staff. You keep your leveling staff exactly at the point A. After that, what do? You bring in your level, your dumpy level, auto level, whichever level you are using. You bring that level here, and what do? You start to do your temporary adjustment. Okay. So this is your, let us say, your dumpy level. You do your temporary adjustment. After doing temporary adjustment, what does the instrument provide me with? Always remember, once in adjustment, once the temporary adjustment everything is completed, the purpose of the level is to provide you with a horizontal line of sight. Okay. So just like we discussed, the instrument is now going to give you what? A horizontal line of sight. So this is that particular horizontal line of sight we get. Okay. Now I'll draw that once again. So what is this? This is the horizontal line of sight that we get. Right. Now what is this? This is the first staff reading that we'll get. This is the first staff reading that we'll get. So you can call that as a backside. You can call that as a backside. But more importantly, tell me about point A. What is point A? Point A is a what? Point of known elevation. The ground point A is nothing but a point of known elevation. Okay. So please understand, apart from saying that the first reading taken is a backside, you should also say that backside is nothing but a staff reading taken upon a point of known elevation. Okay, now this becomes the completed definition. So backside is nothing but the staff reading taken upon a point of known elevation. All leveling work will start from a point of known elevation. Therefore, the first reading is always a backside. The first reading is always a backside. Let me write it down. Okay. So what is a backside? How can I define a backside? So backside will be defined something like this. Okay. Right. Staff reading upon a point of known elevation. Upon a point of known elevation. That is what we call it as a backside. And I can also say like this, right? First reading is always, right, is always a backside. Right, first reading is always a backside. I simply write it as BS. Okay, so that is the first understanding about what is meant by a backside. The first staff reading that you take is what we call it as a backside. It is also the staff reading taken upon a point of known elevation. The next staff reading that we have is what we call it as intermediate sight. Right, the next staff reading that we have is what we call it as an intermediate sight. Okay, now, right. So what do you mean by this particular intermediate sight? It becomes very easy, correct? Na? The staff reading upon a point of known elevation is a backside. Then what would be an intermediate side? Staff reading taken upon a point of unknown elevation. That's it, correct? Na? I hope you can answer me. It's nothing but staff reading taken upon a point of what? Unknown elevation. That is what we call it as our backside. Okay, now? Right. So let me just try and discuss that in the figure here. So this is my point A. Right. Let us assume that there is another point here, say C. Let us assume that there is another point here, say C. Do I know the elevation of C? No, I don't know the elevation of C. What will I do? To find the elevation of C, I should bring in my leveling staff and I should keep my leveling staff exactly upon the point C. I should keep my leveling staff exactly upon point C. Now against this particular point, will I get a staff reading? Definitely I'll get a staff reading. What should I call him as? I should call him as what? Intermediate site. Why will I call him as intermediate site? Because it is a staff reading upon a point of unknown elevation. That's it. That's why we call it as an intermediate site. Okay now? Right. So that's it. That's what we call it as our intermediate site. Let us go back to that terminology. Let me just write down what is this intermediate site. I can write like this: staff reading upon unknown elevation. Unknown elevation. Staff reading upon a point of unknown elevation. That is nothing but my intermediate site. Now who is the third and final staff reading that we have? Who is the third and final staff reading that we have? He is known as your Foresight. Okay, he is known as your Foresight. The third and final reading is what we call it as a Foresight. Okay, so what is a Foresight? I will tell you, Foresight is nothing but intermediate site. What am I saying? I am saying that Foresight is nothing but an intermediate site, which means that it is also a staff reading taken upon a point of unknown elevation. It is also nothing but a staff reading taken upon a point of unknown elevation. But when such an intermediate site, okay, should be called as a Foresight. Foresight is nothing but an intermediate site, staff reading taken upon a point of unknown elevation, yes. But when should I call this particular intermediate site as a Foresight? When it is the last reading that you take just before shifting the instrument. It's the last reading that you take just before you shift the instrument. Such a reading is what we call it as an Foresight. That's it. Okay. So let us go back to that figure here. So imagine that, right? I'm having a point here, say D, right? I need to find the elevation of the point D. So what will I do? I'll keep the instrument at this particular instrument, as in my leveling staff upon this particular point D. This is how my leveling staff upon the point D will look like. Okay, one second. Right. This is how the leveling staff upon the point D will look like. Now I'm telling that after taking this reading, I'm not shifting my instrument. Okay, what am I saying? What I'm saying is, after taking the staff reading upon the point D, I am not shifting my instrument. I'm not shifting my instrument. So please tell me, if I'm not shifting my instrument, what should I call it as? I should call it as the intermediate site only. Okay, so I should still call him as what? Intermediate site only, because I'm not shifting the instrument. Right. Now let us consider another point here, say somewhere around here like this, as say E. Okay, right, that is a point E. I need to find the elevation of the particular point E. What should I do? General procedure is to keep the leveling staff exactly upon that particular point E. So I'll keep my leveling staff exactly upon the point E, right? I'll keep my leveling staff exactly upon point E like this. Okay, right, now that is how my leveling staff will look like. Let me just draw that once again. Okay, so this is how my leveling staff is looking like. Now what is the speciality of this particular point E? Please observe this particular point here. Tell me what do you think is the speciality of this particular point, say E here. See, beyond this particular point E, if I bring down my leveling staff, what will happen? Always remember, the leveling staff is having fixed length. The leveling staff will always have a fixed length. So if I use the telescopic staff, I'll get maximum value of 5 meter. 0 meters at the foot of the staff, 5 meter here, 5 meter here, 5 meter here also. Here also I should get 5 meter. Right. Now almost the 5 meter entire length is utilized now. Now if I keep the 5 meter leveling staff somewhere around here, my entire 5 meter leveling staff will go below the line of sight. The entire 5 meter leveling staff will go below the line of sight. So I will not get any staff reading. So the point I am trying to make is, beyond this particular point E, you may not get a staff reading. Okay, now if you keep the instrument still there, okay, beyond this particular point E, it may be very difficult for us to get any sort of staff reading there. So what we do, as per the field condition, I should shift my staff after taking this reading. So you see here, it is a staff reading, right? Whatever reading that I'm having here is a staff reading taken upon a point, and after this staff reading, I have to shift my instrument. Right? The field condition asks me to shift the instrument. So after this, I am moving my instrument. So that is the last reading taken just before shifting the instrument. What should I call it as? I should call it as Foresight. I should call it as Foresight. Okay. So how can I define Foresight? I write like this. Right. Last reading taken. Last reading taken towards a point of unknown elevation just before shifting the instrument. Just before shifting. Last reading taken upon a point of known elevation, obviously, just before shifting the instrument. That is what we call it as a Foresight. Right. Now let us talk about the next terminology here. These are the three staff readings that we have. Now we need to discuss about a staff station. That staff station is known as my change point. That staff station is known as my change point, or else I can even call it as turning point. I can even call it as what? Turning point. Okay now? Right. So tell me, what is this particular change point or turn point? In this figure, can you tell me who that point is? Is it A, is it C, is it D, is it E? Who is that point? That point is nothing but E here. Okay. So what is this point E known as? I should call E as nothing but change point CP, or I can even call it as turning point TP. Why? Because it is with respect to this particular staff station, I am going to shift my instrument. It is with respect to this particular staff station, I am going to shift my instrument. Okay, because we already established that beyond this particular point, E, it is not possible to take any sort of staff reading. Just like how I promised, I will shift my instrument, try and keep my instrument somewhere around there. Just like I promised, I will shift my instrument there. Okay, let us take these guys out. Yes. Okay. So it is nothing but a staff station. Change point is nothing but a staff station about which the instrument is shifted. That's it. Okay now. Let me write down here. What is my change point? Right. Change point represents a staff station. It represents a staff station. Right. Staff station about which the instrument is shifted. About which the instrument is shifted. That is what we call it as a change point or a turning point. Right. That's that. Now let us talk about the next terminology here. That is what we call it as height of the instrument. Okay. So the next terminology that we should have is about height of the instrument. Okay. Height of instrument. Okay. In short, we can always represent that value as HI. Okay. So what is the height of the instrument? Right. So tell me, looking at this figure here, tell me what is the height of the instrument? Is this height of the level above the ground? That is my height of the instrument, yes or no? Absolutely wrong. It is not the height of the dummy level above the ground. Please remember that. Please remember that. It is not the height of this particular dummy level or auto level above the ground. It's not that height. But in fact, it is the elevation of the line of sight above the assumed data. Please understand, it is nothing but the elevation of the line of sight above the assumed data. Okay, let me just try and explain that here. So please look here, what is this particular point here? What is this particular point A here? It's a benchmark. Right, benchmark is nothing but a point of known elevation. If I say the elevation of this point A is equal to 100 meter, the meaning of this particular statement is that I have a datum here somewhere around here. I'm having a datum here somewhere around here. With respect to that datum, this particular point A is 100 meters above. This particular point A is 100 meters above. What if I say that this backside reading I got is equal to 4 meter? What if I say this backside reading I got is equal to 4 meter? What will be the meaning? From this particular ground point A, this particular line of sight. This particular line of sight is where? This particular line of sight is 4 meter above it. That is the understanding. So now can you tell me, with respect to this datum, what is the elevation of this line of sight? Very simple, it is 100 plus 4. What is the value? 104. You get the value of that particular height of the instrument as what? 104. So I can simply write like this, the height of the instrument here is equal to what? 104. The height of the instrument here is equal to what? 104 meter. Right, but how did you got it as 104? It is 100 plus 4. What is 100? Reduced level of benchmark plus 4 is nothing but your backside. So that is how you calculate the height of the instrument. Reduced level of benchmark from the datum plus backside reading. Okay now? Right. So that's it. That is how we calculate our height of the instrument. Okay. So I'll just take out these values here. Okay. Right. So gone. Let the datum be there. Okay. Right. So let us write down what is meant by our height of the instrument. So height of the instrument is nothing but it is the elevation of line of sight above the assumed datum. Above the assumed datum. That is what we call it as height of the instrument is. Right. Now, what is meant by or what is the formula to calculate height of the instrument? We just found that the height of the instrument is calculated as reduced level of the benchmark plus backside. Reduced level of benchmark plus backside. That is how you calculate the height of the instrument. Okay. Right, so let us go back to that figure here. Let us do some more discussions here. Okay, right. So when I say the height of the instrument is 104, I hope you automatically understand that all throughout this particular horizontal line of sight, the elevation remains as 104. The elevation remains as 104, obviously. Right. So let me just try and give some values here. Okay, right. Let me just try and give some values here. Let me tell you that this particular intermediate sight reading I got is equal to 3 meters. This intermediate sight reading I got is equal to 3 meter. What do you mean by that? What do you understand by 3 meter? It simply, means that your point C is 3 meter below the line of sight. Your point C is 3 meter below this line of sight, right? From this line of sight, point C is 3 meter below. Okay, then what will be the reduced level of C? From 104, I am coming down by 3 meter means it would be nothing but 104 minus 3. I should get the value as 101 meter. Okay, right. So this is how I calculate the reduced level of C. What is it? 104 minus 3. Understand? 104 minus 3, which is nothing but height of the instrument minus 3. So tell me, how do you find out the reduced level of a point? How do you find out the reduced level of a point? It is nothing but height of the instrument minus intermediate sight. Height of the instrument minus intermediate sight, it gives me a reduced level of a point. Similarly, right, what if I say that this particular, intermediate sight reading I got is equal to 1 meter, which means my point D is where? 1 meter below that particular height of the instrument or that particular line of sight. So from 104, I am coming down by 1 meter means what is the reduced level here? 103 meter. The reduced level is nothing but 103 meter, right? Yes. Now let me put this particular Foresight reading as something like say 5 meter. Let me just tell you that randomly I am giving you as 5 meter. What is the meaning? Same meaning only. From this line of sight, my point D is where? My point D is 5 meter below. So what is the elevation of this line of sight? 104. From that 104, I am 4 meter below means the reduced level is 104 minus 5. 5 meter below, na? So then the reduced level of this point becomes what? 99 meters. Right? The reduced level of this point becomes what? 99 meters. But tell me, what is this 5 here? 104 is height of the instrument. What is this minus 5? This minus 5 is what we call it as the Foresight. Okay. So now we get another relation to calculate that particular, reduced level of a point. That is nothing but what? Height of the instrument minus Foresight. That's it. Okay now, right. So that's how we calculate our parameters here. Okay, right. So now what we'll do is, right, once we understand all this particular data, right, what we'll do is, we'll try and, we'll try and represent how the instrument looks like after shifting. Okay, from this particular location, right, we have shifted the instrument. We'll bring the instrument somewhere around here. We'll bring the instrument somewhere around here. We'll do the temporary adjustment, right, and how will be my new line of sight will look like? My new line of sight is going to look something in this particular fashion. My new line of sight is going to look something in this particular fashion. Okay, but tell me, now do you know the height of the instrument? No, you don't know the height of the instrument. Why? Because the instrument has shifted now? Yes, the instrument has shifted, so the new height of the instrument I don't know. But we know the formula to calculate height of the instrument, yes or no? What is the formula to calculate height of the instrument? Reduced level of benchmark plus backside. So the point here is, if you have a backside reading upon a point of known elevation, then you can find the height of the instrument. You see, right, what I'm trying to say, if you are having a backside reading upon any point of known elevation, you can find the height of the instrument. So let us see, once we shift the instrument from previous location to this location here, once we shift the instrument here, do we have any point of known elevation here? Yes or no? Yes. Who is that point? That point is nothing but our E point here, correct na? The point is nothing but our point E. What is the elevation of this particular point E? It has already been established as what? 99 meter. So tell me, if E is a point of known elevation, what should I call this particular reading as? I should now call this reading as a backside because it is a staff reading upon a point of known elevation. Let me tell you that staff reading is equal to 1 meter, which means what is the new height of the instrument? The new height of the instrument will be 99 plus 1, that is equal to what? 100 meters. Okay, the new height of the instrument is equal to what? It is nothing but equal to 100 meters. Okay, 1 second. Okay, so the new height of the instrument will be equal to what? Right, 99 plus 1, it will be equal to what? 100 meters. Okay, so this is how my instrument looks like after shifting. Okay, so now what I need to do? I need to keep my leveling staff. To find the reduced level of B, I should keep my leveling staff at B. Okay, to find the reduced level of B, what should I do? I should keep my leveling staff exactly at B. Whatever reading I get here, what should I call it? Let me ask you one thing. Once I get the staff reading here, is my work completed? Yes or no? Yes. The moment I get the staff reading upon that, staff at B, my entire leveling work is completed. Now, can I take this instrument and can I go home? Yes, I can take this instrument and I can go home. Understand? So this becomes the last reading taken just before I take this instrument and I go home. What should I call that as? I should call that as a foresight reading. Do you remember the definition? Yes or no? Yes, right. The last reading taken just before shifting the instrument should be recorded as a foresight reading. So for that particular definition, for that particular reason, we will call this last reading here as nothing but a foresight. We will call that last reading here as nothing but a foresight. So if I say that the foresight reading is something like, say, 3 meter, what is the reduced level? From 100 I come down by 3, the reduced level of this point becomes equal to 97 meter. So you see, the first reading taken is always a backside. The first reading is always taken a backside. I'll record it as 4 meter. The last reading taken is always a foresight. So while we are writing the definition of foresight, I can add one more point here. Right, last reading taken just before shifting is a foresight, and also last reading taken, last reading in a leveling work, in leveling is always a foresight. Leveling is always a foresight. It is always a foresight. Understand? Right. Now I want you to pay attention here and tell me something. Right. Look at this particular figure that we have made. Right. I want you to look at this particular figure and answer one small point here. Upon my change point here, how many staff reading I have taken? Upon my change point, how many staff readings I have taken? You will clearly see that there are 2 staff readings taken upon a change point. Who are they? Number 1 is the foresight. Number 2 is nothing but the backside. So there are 2 staff readings taken. Who are they? Foresight and backside. The first reading taken on a change point is always a foresight. The second reading taken upon a change point is always a backside. This was SSC JEE question. Right. The first reading taken is always the first reading taken on a change point is always a backside. True or false? Right. The second reading taken on a change point is always a foresight. True or false? This was the question. Okay. So please understand, the first reading taken on a change point is foresight. The second reading that you take on a change point is what we call it as a backside. Okay now? Right. So please understand this point. Upon a change point, both foresights and backsides are taken. Okay. So I'll add that point here. Okay. I'll add that point here. So both backside and foresights are taken on a change point. Okay, so that's it. Right, these are the different points that we should understand. These are the different terminologies, and finally these are the different equations involved, right, in our leveling work. These are the different equations involved in our leveling work. Right. So what I have practically shown you here is, right, the equations involved in our leveling work, and also how the field measurement procedure takes place. Okay, how the field measurement procedure takes place. Okay, so this is one concept that we have discussed here. Okay, now what we'll now do is we'll try and understand how this particular reading has to be entered in my field book. So what is the method of booking? Right, we'll discuss. Okay, the first, or I should say the only method that we'll discuss here today is the HI method. So HI method is nothing but height of the instrument method. So I'll roughly try and tell you, right, what happens in the HI method. So if you are using HI method to record this particular field books, right, or field measurements, what are the different tabulations involved? Can you tell me what is the first and foremost entry? It is nothing but the serial number. Okay. What is the second entry? Second entry is nothing but the backside. Okay. Next staff reading that you take on the field is nothing but intermediate side. After intermediate side, what is the next staff reading you take? It is nothing but your foresight. Right. Now what do? You calculate your height of the instrument, HI. After that, what do? You calculate the reduced levels of all the points, right? And finally, what do you give? You give remark here. Finally, what you give is, you give your remark here. Okay, so the last column here would be nothing but your remark column. Okay, so what we'll do is we'll just quickly try and write down all the different, observations that we have taken from the field. What all observations we have taken in the field in a systematic manner, we'll try and enter it here. Okay, so let us just go back here. Tell me something. Okay, tell me something. What is the first reading that you have taken on the field? Right. What is the first reading that you have taken on the field? Can you please tell me? Right, 1 second. Right, what is the first reading that you have taken? The first reading that you have taken is a backside reading of 4 meter, Where have you taken it? Upon the point A. What is point A? Benchmark. What do you know about the benchmark? Reduced level. Let us write down all these data here. So the first reading that you have taken is nothing but a backside of 4 meter. Where have you taken it? Upon a point A. What is point A? Point A is nothing but a benchmark. What do you know about the benchmark? You always know the reduced level of the benchmark. Right. Now always remember this particular point. Whenever there is an entry in the backside column, immediately you can calculate height of the instrument. What is the formula? Reduced level of benchmark plus height of the instrument. Sorry, reduced level of benchmark plus backside. Whenever there is an entry in backside column, immediately you get one entry in this height of the instrument column. Okay. So tell me, what is the height of the instrument? What will be the formula? Reduced level of benchmark plus backside. I'll get the value as what? 104 meter. That's it. So that is the conclusion after the first reading. Now look at the second reading here. The second reading is an intermediate shaft reading of 3 meters, where I have taken it upon point C. Okay. So the second reading that you are having is nothing but an intermediate shaft reading of 3 meter. Height of the instrument is remaining the same. Where am I taking it? Upon the point C. Now tell me, if you have the intermediate side reading and if you know the height of the instrument, can you calculate the reduced level of C? Yes, we have the formula. Height of the instrument minus intermediate side. You will get it as how much? Right, say 104 minus 3, I'll get it as 101 meters. Okay, now? Right. What is my third entry? Third entry is an intermediate shaft reading of 1 meter. Okay, so let us write down that particular reading here. Third reading is again an intermediate shaft reading of 1 meter. Height of the instrument is the same. Where am I taking it? I am taking up upon D. So what is the reduced level? Height of the instrument minus intermediate side. I'll get the value as 103 meters. Okay. Now this is not exactly very important for gate examination point of view, how to enter it. It is more towards conventional side of view. But I'll tell you why you need to know this. Why you need to know this. Okay, now? Right. So that is 103 meter. What is my fourth entry? My fourth entry is, you see, my fourth reading is nothing but a Foresight reading of 5 meter upon the point E. So let me write down. The fourth reading is nothing but a Foresight reading of how much? 4 meter. Not 4 meter, no? I think I got it as 5 meter. Yes. Foresight reading of what? 5 meter. Height of the instrument is the same. Where am I taking it? I am taking it upon E. What is this point E? It is nothing but the change point. It is nothing but the change point. Okay. So now tell me, if the height of the instrument is 104 and the Foresight reading is 5 meter, what is the reduced level of the change point? 104 minus 5, you will get it as 99 meter. Okay, now? Right. Now pay attention. Now pay attention. After this reading, what happened? After this reading, we have shifted the instrument. You see, after this particular fifth reading here, what we have done? We have shifted the instrument. We have kept the instrument here, did the temporary adjustment, get a new staff reading upon a point of known elevation. What is the staff reading here? The staff reading is 1 meter. Where? Upon the same change point E, I am getting a staff reading of 1 meter. So you see, how will I write it? Upon the same change point E, I am getting a staff reading of how much? 1 meter. What did I tell you? Whenever there is an entry in the backside column, immediately you calculate height of the instrument. Whenever there is an entry in the backside column, immediately you calculate height of the instrument. So 99 plus 1, what is the height of the instrument now? 100 meters. Okay, right. What is the last entry that we have? The last entry is a Foresight reading of 3 meter upon the point B. Okay, so the last entry that we have, the fifth entry that we have is a what? Foresight reading of how much? 3 meters. Where height of the instrument is same. Where am I getting it? B. What you can tell me about B? B is the end of your survey work. So if the height of the instrument is equal to 100 meters, Foresight reading is 3. What is the reduced level of this point? The reduced level of this point is equal to 97 meters. So these are how my data are going to look like. These are how my data are going to look like. Right. Now, am I getting the same values as before? Am I getting the same values as before? Yes or no? Is this correct? You cannot say. Rather, you should not say. Okay. What you should do? You need to apply the arithmetic check. Then only you can say, then only you should say whether your calculation is correct or not. Okay. So you have to do the arithmetic check here. What is the arithmetic check here? What is the arithmetic check here? The arithmetic check here goes something like this. It is equal to, you see, right, summation of all back sides minus summation of all 4 sides should be equal to, you see, last reduced level minus the first reduced level. Last reduced level minus the first reduced level. Let us do that particular summation here. Let us just do that summation here. So what is the summation of all backside? 4 plus 1 is nothing but what? 5 meter. What is the summation of all 4 side? 5 plus 3 is nothing but 8 meter. What is the last reduced level here? 97. right? What is the first reduced level? 100. What we need to take? We need to take the difference between, right, sigma backside and sigma foresight. So 5 minus what? 8 is what? Minus 3 meter. Okay. Similarly, last RL minus first RL is 97 minus 100. What is the value? It is equal to minus 3 meter. So you see, minus 3 meter is equal to minus 3 meter. Therefore, we can write checked. Therefore, we can write checked. That's it. So now you can say that your calculated values are correct or not. Understand? So this is how you apply the arithmetic check. Okay, right. So look at the arithmetic check. Summation of all back sides minus summation of all four sides is equal to last RL minus first RL. The only disadvantage of this particular HI method, especially the arithmetic check, is that there are no checks for our intermediate sides. Right? The disadvantage of this method is no checks, right, on, right, intermediate side readings. Correct now? Right. The back sides are getting checked, the four sides are getting checked, the last reduced are, or in fact the reduced levels are also getting checked, but there is no checks on the intermediate side. So whenever you are having a tabulation, whenever you are having a field procedure where there are numerous number of intermediate sides, the accuracy of this method is always under a question. Right? It cannot provide you enough checks on that particular method, right, or that particular intermediate side. So at this particular point, what we need to do? We need to do our rise and fall method. Right? We need to do our rise and fall method. Okay. But we will be not talking about the rise and fall method here. Right? Right. So we'll take a small break here, and we'll try and understand, right, what kind of questions can be framed from this particular tabulation. Okay, now we'll just take one small 1 minute break. After that, we will continue. Okay. Right.
Regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik, and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik, and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik, and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering.
Right, so welcome back. So we're talking about the method of booking, the height of the instrument method here. Right, I hope you're not having any audio issues. Okay, right, please check your audio from your side also. Right, so that's it. Now, for gate examination point of view, nobody is going to ask you to write this. Obviously, everybody knows that, right? For gate examination point of view, nobody is going to ask you to, do this particular booking method. This is a very, very important discussion for our engineering services point of view, right? So then, how can gate ask a question from this particular side, right? For example, what gate will do is, right? Gate will say that they will give you a tabulation like this, and they'll say find out the missing value. Okay, they will ask you find out this particular missing value. Like that, gate can ask, na? Yes. Right, now when they are giving you this particular missing value type of question from this particular tabulation, right, how can you find that particular missing value x? Should I go with this height of the instrument method or should I go with the rise and fall method? Generally, you don't have to go with that. You just need to apply the arithmetic check. You see, the missing foresight is there, sorry, the missing data is nothing but a foresight. And this foresight is nothing but part of our arithmetic check, yes or no? So if I am simply able to apply the arithmetic check here, I'll be able to get this particular missing value x. You don't have to go with the HI method or the rise and fall method, right? And also I would like to say that we have taken some simple values here, 4 meter, 3 meter like that. Now in the actual field, we are not going to get an exact integer value like this. We are going to get a decimal points only. Right, and also apart from that, what they'll do is that they will say that these are all nothing but negative staff readings. These are all nothing but negative staff reading. Like that they'll say. Okay, this back side is negative side, this back side is negative side, this intermediate side is also negative side. So now if you do your calculations that has HI method or rise and fall method, yes, you can get it, but in the hurry of the examination, you may get some small confusion. To avoid all such confusion, just apply arithmetic check to find out this missing value. Right, that's it. That is what you are supposed to do. So like that, they can frame a question in your gate examination. Right, remember that. Okay, right, now the question is, what is this negative staff reading? Right, what is this particular negative staff reading? Right, so far we did not see any negative staff reading, na? Yes. What is this negative staff reading? Can anybody please tell me what is the negative staff reading is? What do you mean by negative staff reading? See, it's nothing but what we call it as inverted staff reading. Negative staff readings are nothing but inverted staff reading. Let us go back to the figure that we have drawn here. So please look at this particular field condition that we have represented here. Please look at this. Right, look at all the points here. Say A, C, D, E, B. Look at all these points here. Look at my line of sight here. Right, this is my first line of sight, second line of sight. Where are these points with respect to my line of sight? Are they above the line of sight or are they below the line of sight? No doubt they are lying below the line of sight. But what if we need to find out the elevation of a point lying above the line of sight, right? What do? Go for the next type of staff reading. We call them as inverted staff reading, okay? So this is an area from which gate has asked multiple number of times. Gate has asked multiple number of times, and almost all PSC examinations also, they extensively ask from this particular area. What do we call this area as? We'll just call this area as the inverted staff readings. We call this particular area as inverted staff, okay? Or I can call it as inverted staff reading. Okay, right. So what do you mean by inverted staff reading? What do you mean by inverted staff reading? See, whenever it is required to find the elevation of a point that is lying above the line of sight, we call this point as an overhead point. What we do? We take our leveling staff, hold the leveling staff inverted, touch the overhead point with the foot of the staff. Touch the overhead point with the foot of the staff. So you see here, this is the foot of the staff, this is how my leveling staff is looking like. We call this particular staff as an inverted staff. The reading against such a staff is what we call it as inverted staff reading. That's it. Okay, that is what we call it as the inverted staff reading. Okay, na? Right. So when do we go for inverted staff reading? Whenever we need to find elevations of points that are lying above the line of sight. Okay, na? Overhead points, we'll go for inverted staff reading. Okay, na? Right. So let me just write down here. Right. When do I go for inverted staff reading? Okay. Right. When it is required, to find the elevation of a point lying above the line of sight, the staff is held inverted. Staff is held inverted with the foot of the staff, touching the overhead point. Touching the overhead point. Okay. Touching the overhead point. Okay. Readings against such staffs are known as inverted staff readings. Okay, now inverted staff readings, and they are always represented with the negative side. Always represented with the negative side. They are always represented with the negative side. So remember that. Okay. So this is what we call it as our inverted staff reading. Okay, now. Okay. So this is what we call it as our inverted staff reading. Okay, now, right. Very, very important concept. Multiple times GATE and engineering services have asked questions from this. Okay, right. So let us just try and represent that figuratively. How does this particular condition looks like in the field? So imagine that this is the ground condition that you're having. One second. So you can imagine that this is the ground condition you are having. Okay, right. This is a point A. Right. I'll call it as a benchmark. I'll call it as a benchmark with an reduced level of 100 meters. You are having a building here. Okay, we are having a building here. This is the, right, the parapet level of the building, right, sorry, the sunshade level of the building. You can even sometimes call it as the chajja of the building. You might have come across that particular terminology, right. So, right, what we do, we need to find out the elevation of that particular point. So, first and foremost, to find the height of the instrument, we need to take the backside reading upon this particular, point A. Do your temporary adjustment, line of sight will come like this. This reading here will be known as what? Backside reading, because it's a staff reading upon a point of known elevation. I'll call that particular reading as, say, something like 2 meters. Now, to find the reduced level of this point, what will I do? Take my staff like this, hold it inverted, touch the overhead point with the foot of the staff. This is how your line of sight, the staff is going to look like. Against this particular staff, you will get a staff reading here. This is the point that I need to find out, therefore I call this as the Foresight reading. Let me tell you that the Foresight reading I got is equal to 4 meters. Right. So how do you find out the elevation of this particular point here? Right. Let me just try and record the data here. So the backside reading here is equal to what? 2 meter. What is the Foresight reading here? The Foresight reading here is equal to minus 4 meter. Why? Because it is an inverted staff reading. Okay, now, how do you find the height of the instrument? The height of the instrument is equal to reduced level of benchmark plus backside. Okay, the reduced level of benchmark is 100 plus backside is equal to 2. You get it as 102 meters. Okay, now can you tell me what is the reduced level of the unknown point B? How do you calculate the RL of B? Right? How do you calculate the RL of B? So now, what is the formula? Reduced level of the unknown point is equal to height of the instrument, right, minus Foresight. Never change the formula. Never change the formula. Directly write down the original formula only. What is the height of the instrument? Height of the instrument is 102 minus what is my Foresight reading? My Foresight reading is C. You see here, it is minus 4. So it is minus of minus 4. You will get the answer as what? 102 plus 4. You will get it as 106 meter. That is a reduced level of the last point here B. That is the RL of the chajja of the building. Right. This is how you can solve it in your university examination. Do not solve like this in your competitive examination. Nobody cares about your step. I told you this yesterday. Nobody cares about your step. How you reach the answer is not really important. Right. How quickly you reach the answer is very, very important. Okay, now? Right. So let us try and understand how quickly we can solve this without writing these many number of steps. Right. So tell me something. Right. What do you mean by this particular staff reading of 2 meter here? What do you mean by this particular staff reading of 2 meter here? It practically tells you that this particular line of sight, it is 2 meter above this particular 100 meter level. Okay, na? What do you mean by this staff reading, inverted staff reading of 4 meter? Remember, the foot of the staff is always 0 meter. That means this particular point B is 4 meter above my line of sight. So you see, the line of sight is 2 meter above the benchmark. Okay, from this line of sight, point B is 4 meter above. You see, right, from this 100 meter, my line of sight is 2 meter above. From this line of sight, this particular point B is what? 4 meter above. So tell me, what is the easiest way of finding the reduced level of B? The easiest way is nothing but 100, I rise by 2, so 100 plus 2. From this level, I rise by 4, you add 4 here. What is your answer? 106 meter. That's it. Your answer is nothing but 106 meter. This is how you solve it. Right? For your competitive examination, your multiple choice question examination, this is how you are supposed to solve it. What you do is read the question. Okay, na? Read the question very carefully. Draw 3 lines. Represent who is above, who is below. Read the question, okay, and draw the figure. Who is above, who is below. Where is the inverted staff? Where is the direct staff? That's it. Now look at the figure. Find the answer. Right? That's it. 3 lines you draw. By the end of the 3rd line, you will directly get the answer. Okay. Try like this 3 times. 4th time, without drawing the figure, you will say the answer. Because you try to visualize how the figure looks like. When visualization is possible, the answer come, within a second. Okay. So this is how you solve questions from inverted staff reading. We had a small discussion of how height of the instrument method is done. Right. The procedure of booking is not important for GATE. Absolutely not important for GATE. Terminology is what we discussed. That's very, very important to understand. And also, right, missing data. Right. When they give you a tabulation, find out the missing data. That is also a GATE model problem. Inverted staff reading is also a very, very important area in GATE examination. It's a frequently asked areas. Okay. Right. So you solve it by drawing 3 lines and by writing 1 equation. That's it. Okay. So this is almost our time. So thanks a lot. I wish you all the very best. Right. I hope you take note of whatever things that we discussed yesterday as a guideline. Right. So please, try and better yourself. Please try and compete with yourself every day. Definitely you will find success. Thanks a lot. I wish I'll see you again anytime, sometime very soon. Okay. So all the best for all the aspirants. Prepare very well. Right. Nothing is, beyond your reach. Okay. If you have that dedicated hard work, nothing is beyond your reach. Okay. Thanks a lot. All the best. Bye-bye. Jai Hind.
My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation,